This is number 2 from section 2.2. Let's read the instructions. Use a given inverse of the coefficient matrix to solve the system. Okay. All right, so you might recall, and we did this quite a while ago in one of the sections, that you can always change a system of equations into a matrix equation. If you write down the coefficient matrix and multiply it by the column variable matrix, and then set it equal to the constant matrix, that's equivalent to the original system. And you can use matrix multiplication to check for yourself that it's true. All right, but they've essentially given us the inverse of the coefficient matrix. So if I started off with a matrix equation that looked like this, and I wanted to get x by itself, I would just multiply on the left by A inverse. Because by definition, A inverse times A is just the identity matrix. And the identity times anything is just the anything. So notice you'd get a solution of the system just by multiplying on the left by the inverse of A. So that's what you're supposed to do. So I'm just going to take this equation and rewrite it, but I'm going to multiply on the left by A inverse, just like I did here. All right. Or, the other way to do it, I suppose, is just to use this equation. Maybe that'd be faster. So A inverse is this. I'm just going to multiply it by B, which is that constant matrix on the right. And let's see what we get. Well, using row times column, it would be -8 minus 4. And then 24, and I guess that'd be plus 10. So it looks like the solution is x1 equals -12 and x2 equals 34. So matrices are really a lot more useful for solving systems when you have a lot of equations as opposed to just 2.